Natural gas, the cleanest burning fossil fuel, is abundant and affordable. Most people are familiar with the gas. It is the same gas used for cooking, heating homes, and generating power. To change the gas into a liquid, you have to cool it down to very, very low temperatures of minus 260 degrees Fahrenheit, which is about minus 160 degrees Celsius, because very few places can keep it that cold. Liquefied natural gas, or LNG, is not readily available to most people.
LNG is natural gas in a liquid form. It's odorless, colorless, non-toxic, and non-corrosive. LNG is not a new fuel. It has been safely handled for more than 50 years. We have a small amount of LNG here today to show you some of the basic characteristics of this literally cool fuel. Natural gas is liquefied because doing so reduces its volume 600 times. That's like shrinking a beach ball into the size of a ping pong ball, so it's easier to store and ship long distances. LNG is very cold, but it is not corrosive. As Menine pours some LNG directly onto this cookie sheet, which is about room temperature right now, you can see the LNG quickly evaporating as it beads and slides along the pan. This is because the pan is so much warmer than the LNG. It's actually the same effect you get when you rinse a hot skillet with cold tap water in your kitchen.
Let's see what would happen in the unlikely event that LNG spills on the ground. The soil is much warmer than LNG, so it evaporates quickly. It doesn't seep into the soil or leave any residue. You can see the ground is not wet or sticky, although it would freeze any moisture that's in the soil.
Ever wondered how cold minus 260 Fahrenheit or minus 160 Celsius is? It's far colder than most people can even imagine. Let's take a marshmallow. It will take no time to freeze when Menine dips it in the LNG. As you can hear, the marshmallow is now frozen. We're going to set it aside for now and come back to it in a few minutes when it's had a chance to thaw.
Some things become brittle when frozen in LNG. This lovely fresh-cut daisy will become stiff and brittle when Mariah dips it in LNG. As she crushes the flour, it breaks as though it was made out of glass. Because we are aware of this phenomena, special metals and materials are used to contain and handle LNG. Because we know LNG is non-toxic, we can dip a graham cracker into LNG. And after it thaws a bit, we can eat the cracker.
Cheers.
Cheers. All the LNG has evaporated off the cracker and it tastes great.
Very good.
Let's see what happens when LNG comes into contact with water. The LNG is so much lighter than water, it floats on the surface. Water is also warmer than LNG, so the LNG immediately warms and evaporates. Now you notice some ice crystals on top. That's just because of the really cold LNG temperatures. There is no residue left over. LNG has been shipped across the ocean for more than 50 years and has a very strong safety record. But in case of a spill on the water, no spill cleanup is required. So we can actually drink this very cold water.
Remember that marshmallow we stuck into the LNG? It was frozen then, and very hard. Well, guess what? It's returned to its original form. Oh, and the marshmallow itself? Back to normal.
LNG, which is simply natural gas that has been cooled to the point it becomes a liquid. It's the cleanest burning fossil fuel. Let us illustrate what that means. Mariah will hold this glass beaker over the candle, and watch what happens. You can see black carbon residues start to form. But if I do that over this natural gas candle, there's hardly any residue, as you can clearly see. LNG vapors will ignite only if the ignition source is more than 1,000 degrees Fahrenheit, or 500 degrees Celsius. That's pretty hot.
Yeah.
The cigarette that Mariah is holding burns at a temperature of around 700 to 800 degrees Fahrenheit, or 350 to 450 degrees Celsius, much lower than the temperature needed to ignite the natural gas. which is why she can pass the red-hot cigarette through the LNG vapors without even igniting it. In fact, Mariah can extinguish the cigarette in the LNG because there isn't enough oxygen in the container to keep the cigarette lit.
We've added some LNG to this flask. When the LNG evaporates, it returns to a gas. Manine has attached a balloon to the LNG vapors coming off the LNG in the flask. Now let's convert that natural gas back into a liquid. As Manine cools the gas of LNG, you see the balloon is contracting because the gas is cooling and becoming a liquid.
We hope you've enjoyed learning about the basic properties of LNG. As we've demonstrated, LNG is simply natural gas, the same natural gas that is used in homes all across the world, that has been cooled to the point that it becomes a liquid. In its liquid form, LNG does not burn. LNG vapors will burn when mixed with oxygen in a 5 to 15% ratio and combined with an ignition source of at least 1,000 degrees Fahrenheit, which is what makes the fuel valuable.
LNG is stored at minus 260 degrees Fahrenheit or minus 160 degrees Celsius to keep it in its liquid form. LNG has been used around the world for more than 50 years and has an impressive safety record. It really is a cool fuel.